Hey, hello, and welcome to the show. Oh my gosh, there's so many windows there. It's me, John Park, and it's time for another JP's Product Pick of the Week. So thanks so much for stopping by, for joining us over in our YouTube chat and the Discord chat. And that's where things are happening, in case you're wondering, in case you're over on Twitch or LinkedIn Learning or one of the other, not LinkedIn Learning, LinkedIn, what do they call that stream? I forget now. The LinkedIn stream? Facebook, those are places. And we broadcast there, but the chat is happening largely in our Discord, and that's at adafruit.it/Discord. If you're wondering where it's at, that's what it looks like right there. There's a nice little conversations going on there. Rich Sad, Jim Hendrickson, C-Mac, Mike P. Hello, Dexter Starbird. Nice to see you. And we've also got Tackle the World, John O. and Roy Kazitsky and Dave Odessa over in YouTube. Hello and welcome. So let's see. Let's get on with the show. First thing I want to do is send you to the URL where you will find our product pick of the week this week, in case you want to head there and get a jump on it, because we've got a big honkin' discount. It's going to be a 50% discount today on the product pick of the week. So I'd love for you to jump on that. And this show is broadcast from inside the page, so you can head there, watch the show, and learn a little bit more about the product. And buy one or more, up to 10 if you like. So let's see, what I'm gonna do next is have Lady Ada tell us a little bit about this product pick by jumping back to her new product of the week segment when this originally was released. So take it away, Lady Ada.
It is the STEMMA relay. So this was designed a while ago by request by Bill B. He's like, I want an easy way to plug and play different relays. And we had relay feather wings, but they weren't easy to attach solderlessly. So this lets you, because there's a STEMMA connector on it, the JST 3-pin connector, it's easy to connect it with alligator clips or breadboard wires without any soldering at all. And also the terminal blocks are SMT terminal blocks that don't require a screwdriver to use. All right, so this is the lamp, and then if you go to the overhead, I'll show what I built here. So this demo has a Circuit Playground Express, but you can of course use any microcontroller board. And I just have it blinking red and green NeoPixels so I know what it's doing. And then what's nice with the STEMMA is you can use these alligator clips. So you plug in the alligator clips onto this, or you can use a microbit, and then that plugs into here. So this can do up to 60 watts. It's a 60-watt light bulb, so it's convenient. Up to 240 volts, or 110 to 240 volts. And you can use it with resistive or inductive loads. With inductive loads, you do have to derate it a little bit. So what I'm going to do is I'm going to turn this off, and I'm going to unplug it. So these terminal blocks are a little bit different than what most people are used to. So I want to show those because they're a little bit unusual. So usually terminal blocks use screws, but this is the first time we're using these terminal blocks that have these little nubs, and you can just use a pen to push down, and then you can remove. Hold on. Live demo. Oh man, that's not coming out. Hold on.
Man.
Well, it was totally working earlier. There you go. You just have to like really press down.
Yeah.
And if you have two hands, it's tough. Maybe you can pull it while I press down.
What do you want to just pull it out?
Yeah.
Okay.
So, I'm going
So
to,
you press that down and then you go
there
like
you
that.
go.
Yeah.
Thank you.
Cool.
Tough to do on video. And then if you want to plug wires in, you don't need to use a tool. You actually just press them in, and they latch in. Hold on. Let's do this one. I'm not having good demo fun. Okay. There you go. So when you press it in, there's a little clip inside that grabs the wire. So you just have to make sure you have enough wire stripped off the end, and then you just have to push it straight in, and then there's a little clip on the inside. There you go. That grabs the wire, and you'll feel it, and then you can't really easily. I mean, you could pull really hard, you can yank it out, but for the most part, these are really stuck in quite nicely. So it's no screwdriver required for the terminal blocks, which is kind of neat. And then with the JST cable, we have different cables. This one is alligator clip, but we also have one that has plain wires for breadboards or sockets, so you can use it with a Raspberry Pi or Arduino. And the STEMMA relay will work with 3-volt or 5-volt logic and power. So either way, it's kind of a all-in-one. You don't have to worry about the flyback diode. You don't have to worry about an LED. You don't have to worry about the current on the signal pin. That's all taken care of for you. It is the STEMMA relay. So this is actually.
Whoops, I didn't set that to hold, so I'm just going to loop. Yes, so that is it. Let's in fact jump to my little mystery box that I've got right here with one of this week's products loaded right into it. This is, by the way, the standard government issue L703D6-49 mystery box, a good one, good vintage. So let's check it out. Ooh, yes, there it is, fresh in the bag. I opened it, but I haven't even taken this one out yet. And that is it. That's our product pick of the week. It is the STEMMA mini relay breakout board. It is a non-latching relay. It is controlled by 3 to 5 volt control voltage, and you can use it to pass anywhere up to about, I think, 250 volts AC or DC. At 120 volts or 110, you get about half an amp current draw safely through this, and then more as you go to some of the sort of lower voltages with DC. So cool features of this. This has the STEMMA port. Now, we talk about STEMMA QT a lot on this show. STEMMA is this 3-pin JST. So this is just a signal, power, and ground, which you can control from pretty much any digital pin on your microcontroller. It's not I2C. It's just a straight, easy connection to a pin. It makes it easy to plug and play. And as Lady Ada said, we have a lot of different cables for this. This is a nice one here. This is the one I'm going to use in my demo. Let me move the mystery box here. So this type of cable allows us to just plug into some header sockets with the signal on white, ground on black, and power on red there. We also have a socket version of that, so if you have something with pins sticking up out of it, you can plug that on. And then we also have, you can see here, I've got the alligator clip variant of it. So you just plug this end in here, and we are ready to control one of the pins, or rather, we're ready to control the relay from one of the pins on your microcontroller. So let's jump over to the product page for a moment. Here you can see it, and if I reload, we should see that this is now a terrific price, $2.98. It's half priced, and the nice thing about this is that you don't have to worry about setting up any of the rest of the circuits. Normally when you drive a relay, you are going to be concerned with setting up a flyback diode so that you don't have that collapsing electromagnetic field wreak havoc. None of that is necessary. It's all set up for you on the board, so it's easy to go. And let's see, you've also got on here a little, if you can see it there, you've got a little set of pins that you can plug in an optional screw terminal block if you don't want to use these, but these are great. You can see in that video they are definitely hard to remove the wire from, so they really grip it nicely, which is good. Thinner wire is going to come out easier, I think, but Lady Ada in that demo was using sort of lamp wire. And you can see the stats on it on the back. The center pin here is common, and then you can either use a normally closed or a normally open pin on this. So let's get to a demo. Actually, before we get to a demo, let's take a look from this page, from the product page. If you scroll down, you will see that there are a couple of learn guides related to this. If you click the first one, you'll go to check out the primary guide for it, the main guide for it, which tells you everything about the pinouts, all the specs and stats, and a couple of little usage demos. But essentially, if you can blink an LED, if you know how to set a pin to high or low, then you can drive this little relay board, and you can have some really larger things plugged into it to control lamps, fans, things like that. Some example projects that you might do with it. Here's one that Isaac Welch did, which is a room occupancy status, what is it? No code room occupancy status. So this one doesn't even use a microcontroller. It's just using a PIR sensor that can set a pin high or low, sort of built into it, no coding required. So for my demo, what I'm going to do, let's go back to our pure down shooter shot here. And I'm going to slide some things into view. And what I've got here is a little cutie pie. I'm going to refocus here 1 second. Pretty good. And I can get it a little closer, I think, too. That's pretty good. So I have a cutie pie here that I've attached some little right angle headers to so I can plug in my power ground and signal. I'm using signal over the MOSI pin here, but you could use any digital capable pin. And then I've got a standard sort of 110 light socket here, some old IKEA lamp with a LED bulb plugged into it. But this could be an incandescent if you wanted to. Just make sure that you're within about a half a amp usage in this scenario. And then for my connection over to the STEMMA QT relay board, rearrange things here, you can see what I've done is I have a lamp plug that's plugged in to my AC power, and then I'm using one of these nice Wago connector nuts to connect one line, and the other is going into common, and then my lamp wire, which is this sort of cloth covered wire, is going into the normally closed side of this. And so if we take a look at the code I've got running here, let me shrink this a bit and move that out of the way. Set that over there. Okay. So what's going on in code here is I'm treating this essentially like any pin that you would drive. So I'm bringing in the digital I/O. 1 second. There we go. So I'm importing the digital I/O library. Then I'm setting up a variable called relay pin, and on that I have a digital I/O, digital in, out, and I'm specifying the board's MOSI pin. This could be any digital pin. Then I'm setting that direction to be an output pin, and I'm initially setting it to false, which means it's not going to trip the relay. If I just simply change this to true and hit save, bam, we have our light bulb going off. So you can see I'm sort of terrifyingly underlit now. And wow, I'm blinded. Now I can just undo that and hit save, and it's going to turn that right back off. So if I, instead of just setting that, one true or false, if I set up a little sort of blink command here, so I'm sleeping for 4 seconds, then I'm setting the value to high, then I'm sleeping for 4 seconds and setting it to low. So I'll hit save on that, and now you'll see every 4 seconds it's going to turn on, hold for 4 seconds, and then it's going to turn back off. Okay, and so you can imagine now you have the power to control that using something else. It could be an IoT thing, it could be a sensor-based thing, it could be random, but I'm now able to control that lamp safely and easily, even though this is, you want to be careful with this. This is high voltage stuff that I'm doing here. But the way I have this set up right now, it's fairly safe and easy to deal with. Now, you may want to use electrical tape Kapton to really, or even heat shrink to sort of shrink up this whole thing to make sure no one can touch any dangerous parts of it. But it is, if you're interested in doing high voltage stuff, a good way to do it. You can, of course, also do low voltage things, 12 volt types of things, 5 volts, whatever you want in DC. All right, so let's see. Let me pause that there. What I'll do is just resave that code. Oh, it's going to yell at me because it's not going to pass when it gets there. There we go. So that's turned it off. And if I unplug the bulb, so what I'm going to do is actually I've got a switch that I can turn off that. What you'll see is on this, actually is this, I don't think I have I don't have a status LED on here, do I? I don't think I do. But you could set that up, as you saw in the demo that Lamore did, to turn on some neopixels or a little status indicator to light up a little LED, and it's really doing the same thing. All right, so let's see. Let's check in on the chat if there are any questions. Mike P. asks, non-latching means it'll go low if power is lost. That's correct. In fact, let's demonstrate that. So I'm going to turn the power back onto the AC power line that's running here. I will run over to my code window here. Let's set this to true and hit save. So it just turned on the power by magnetizing or energizing the magnet and coil for the relay in there. So it's essentially a little magnet that's pulled the switch closed. If I remove power headed to that relay one way or another, if I unplug the Cutie Pie or just unplug one wire from this, it is now going to use a spring to go back to its open position. So that's what a non-latching relay will do. And you'll notice when I plug it back in, it's not like it resets it or anything like that. So I would have to resave this code or whatever the condition is that causes that to be energized would have to start again. So let's see if I can reset. There we go. So yeah, that's a great question. That's what the latching relay or versus non-latching relay is all about. Let's see. I'll resave that. Okay. Any other questions? Let's see. If there are no questions. Oh, here's one, and I don't know the answer to it. Tackle the World over on YouTube asks, Wago or Wago connector pronunciation? I don't know. W-A-G-O, that's these nice sturdy connectors here, and I don't know how you pronounce that. Wago? I've heard Wago more, I think. That's probably what I've said. All right. And yeah, Bill, AT-Maker Bill is in the chat over on Discord, and he got the call out, shout out from Lamore. It was, I think, Bill's request to get a nice little neat relay. I've built these kinds of things in the past when I had relay types of projects that used multiple. I've made little like perf board things like this. So it's really nice to have a simple, ready to go. It's got mounting holes on it. It's very easy to use. Rich Sadas, is there, I think he means, is there a latching similar product? No, I don't think we have this as a latching relay version. I think we only have the non-latching. We do have your Featherwing as a latching and a non-latching. And Bill asks about the right angle. These are actually, we sell these in the store, I think. These are right angle. I didn't bend them. These are right angle header pins that I just trimmed down and use. Yeah, I like that arrangement for keeping things low and flat. All right, so we can jump back on over to this here product page and get ready to finish things up. So yeah, there's the product page right there. That's your STEMMA non-latching mini relay. Do we still have them in stock? Let's reload this and see. It's always exciting to see. Yes, we do. So go fill up your cart with them. You can get up to 10 of them and turn some things on and off with relays. It's lots of fun. Let me pull this screen off of here, and I'm going to use one of these JST connectors as my hanger there when I put that on the board. So that right there, that's the product pick of the week. It is the STEMMA non-latching mini relay breakout board. And that's going to do it for the product pick of the week for Adafruit Industries. I'm John Park, and I will see you next time. Thanks everyone for stopping by. Bye-bye.